9.2 is about area of triangles and parallelograms. So the first thing we're going to go through is the area formula for squares, rectangles, parallelograms, and triangles. Remember, all of these formulas will be given to you on the test. You just need to know how to use them. To start off with square, that one is pretty easy. You should all know what that one is. The area of a square is just the length of one of its sides. And then you're going to raise that to the power of 2 because all of the sides are congruent in a square, and then it has 4 right angles. Then we have a rectangle, and the area of a rectangle is just the length of the base and then the height multiplied together. And the nice thing about a rectangle and a parallelogram is that those two have the same area formula, so base times height. And when you're doing the height here, you want to make sure you're using the vertical height, not the slant height. So this one you do not want to use. Okay. And then lastly, we have our triangle, which area of a triangle is 1/2 the length of the base times the height. And again, this one we're using the vertical height, not the slant height. And I apologize if you can hear my dog eating in the background. Okay. So for example 7, they want us to find the area of ABCD. So this one is not a square, not a rectangle, but it is a parallelogram. So once we have that, we know that the area of a parallelogram is the length of the base times the vertical height. So if we look at this one, the base is just going to be the length of the shaded part. So that one is going to be 9. And then our height is going to be the vertical height, which is 4. Now the 4 is not inside of the shape, but it's still telling us the height of the parallelogram. So it is okay to use that in our area formula. So this one, our area is going to be equal to 9 times 4. And that will end up being 36 units squared. And that's our answer. Okay, so then our next one, they want us to find the area of the triangle. So this picture, they give us more information than is needed. Area of a triangle is 1/2 base times height. So in this one, we need to figure out what our base is, and that is the entire length of the bottom of this triangle. So we're going to have to take 45 plus 21 to get 66. So in for the base, we're going to plug 66 in, and then we're going to use the vertical height. So we're going to use 28. And a lot of common mistakes is people would use 35 or 53 in this case, but those are not the vertical height, so we do not want to use that one. Once you're there, you can just plug all of this into a calculator, and you would end up getting getting 924 units squared. All right, so for some of the problems, you're going to be given the shape, and then you have to calculate the area. Other times, you're going to be given word problems, and you are going to have to solve for a variable. So for example, 9, the base of a triangle is 4 times its height. The area of the triangle is 50 square inches. Find the base and the height. So let's draw a picture. It's a triangle, so you can just draw any general triangle. And then I'll draw in an altitude for the height. And the base of the triangle is 4 times its height. So if we have its height here, the base is going to be 4 times that value, or 4h. And the area is 50 square inches. So we're going to plug everything we know into our area formula, which is 1/2 base times height. This time we know what the area is, so we're going to have 50 equals 1/2 the base, which is 4h, times the height, which is h. Once you have the equation, then you just want to go through and solve. So we would have 50 equals, then we can multiply 1/2 and the 4 together, which would be 2. And then we would multiply h times h, which is going to give us h squared. And then we can divide both sides by 2, and we will get 25 equals h squared. And then we need to take the square root. Normally you get 2 answers when you take the square root, but because this one we are talking about a shape and measurements, we're going to leave the height as only a positive 5, which means our base would be 4 times 5, or in other words, it would be 20. And those would be our 2 answers. With this, you want to make sure you find both parts after you find the value of the variable. Okay, for example 10, this shape is not one of our formulas, but you can break it up into pieces that would be a part of our formula. So we have a square because the entire height is 9 and this part is 5, which leaves this last part to be 4. And then same thing going the other direction, the whole length is 9 and this part is 5, leaving this piece here to also be 4. So that means we have a square over there, and then we have a rectangle that is a 5 by 9. So when we find the area, one way to do it is to take the area of the square plus the area of the rectangle. And our square is just going to be one side length squared, so 4 times 4, or 4 squared. And then the area of our rectangle is base times height, so 5 times 9. Excuse me. So then you're going to go through and solve this. 4 squared is 16, 5 times 9 is 45, and then we can just add those together to get 61 meters squared for the total area. So sometimes you're going to have what's called a composite shape. That's what this one is, where you're going to have to find the area of multiple different shapes before you can find the total area. Okay, next example, 11. This one is a parallelogram, has an area of 133 feet. So we're going to use the area formula to solve for missing pieces. The next thing they tell us, it has a height of 19, and they want us to find the length of the base. So if we plug that in, our area is 133, our height is 19, so we would have 19 times the area of our base length. And this one is pretty easy. We just have to divide both sides by 19, and that will tell us that our base is equal to 7. So other times they're going to give you an area of the shape, so you're going to plug that into your area formula with the other pieces of information you know, and then solve for the missing piece. Okay. The last 2 examples, 12 and 13, these ones are from this unit still, and then the review questions are going to be from 9.1 to just refresh our memory from last week. So for number 12, it tells us the diagonal of a square is 12 square roots of 2, and the diagonal, remember, connects 2 opposite vertexes. So we know in this square, this is 12 square roots of 2. And in a square, don't forget, all 4 sides are equal to each other. And we have right triangles, and these 2 angles would be congruent because the diagonal of a square cuts the opposite angles in half. So in this one, we do have a 45, 45, 90 triangle. So if you can remember that for a 45, 45, 90, that the hypotenuse is equal to the leg times the square root of 2, you can use that equation to help you solve for the legs. If you don't remember that, you can still use Pythagorean theorem. So for this one, if you use Pythagorean theorem, you would have x squared plus x squared, because those are the two legs, equals 12 square roots of 2 squared. The important thing is if you use this one, you have to put parentheses here, otherwise your answer will be wrong. So x squared plus x squared would be 2x squared equals, and then you have to square both of these parts. So that's going to end up being 144 times 2, which will give us 288. And our goal is to get x by itself, so we can divide by 2. Now it would give us x squared equals 144. And then we would take the square root of both sides. And that would give us our side length of 12. So each side is going to be 12, which we would have also got that from our special right triangles, if you remember that, because we would just divide both sides by the square root of 2. And that gives us 12 is the leg. So two different ways you can do it, special right triangles or Pythagorean theorem. For this one, they wanted us to then find the area of the square. So area is just that side length squared, and in this case, that would be 144. Okay, so then example 13, if you want to pause and try that one on your own. This one is also a square. This time our diagonal is 15. So if we set up Pythagorean theorem again, or you can use the special right triangles if you remember that, we would have x squared plus x squared equals 15 squared. And then if we combine our like terms and square 15, we're going to get 225. Then we would divide by 2. And that gives us x squared equals 112.5. Now remember, with these problems, we don't want to round anything until our final answer. And we want to find the area. So we know that each side is equal to the square root of 112.5. So we're just going to use that when we find our area. So the area of a square is just the side length squared. And when you square a square root, these cancel each other out, and you are left with 112.5 units squared for our area. So that's everything that's new from today. The next 4 questions, those are just a review. So for the review question number 1, what is the sum of the exterior angles of an octagon? And whenever you have the exterior angles and the sum, that is always 360 degrees. So this one, there's no work to do. It is just remembering that the exterior angles always add up to 360. Then for question number 2, what is the measure of one interior angle? Sorry about that. One interior angle of a decagon. So the measure of an interior angle of a decagon, this one has 10 sides. So remember, if we're looking for one angle, we find the sum of all of them, which is n minus 2 times 180. And then we divide that by the number of sides. So in this one, I'm so sorry about my dog. In this one, our n value is 10, so we would have 10 minus 2 times 180, all divided by 10. And this is what we would use to plug into our calculator to figure out what that angle would be. And once you get that typed in, you should get 144 degrees per angle. So So this is when you're looking for one angle. You would use this formula. Or if you are given one angle and you're looking for the number of sides. The next one, they are asking you for the sum of the angles of a pentagon. So whenever you're looking for the sum, that's when you only use the top part of that equation, where you take n minus 2 times 180. And a pentagon has 5 sides, so we would be able to plug that in, 5 minus 2 times 180. And if we plug that into a calculator, we would get 540 degrees. So this one is when you're looking for the sum of all the angles. All right, and then the last thing we went over was area of regular polygons. And the area formula for regular polygons is 1/2 the apothem times the perimeter. And this one, they only gave us the radius. So we have to figure out what the length of the apothem is, and we have to figure out what the side lengths are to find the perimeter. So if we draw this triangle formed by the two radiuses, we know that each of those is 12 on the side of our triangle. And we need to figure out what the length of the apothem is and then the value of x, so we can then find the perimeter. In order to do that, in this one, because we only know one side, we have to figure out what this angle is at the top. And if we look, this shape has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one has 10 sides. So when we find that angle, we're going to take 360, because that's the total distance around, and we're going to divide that by 2 times the number of sides, and that's so we can get half of the central angle. So in this one, we're going to have 360 divided by 20, and that is going to equal 18 degrees. Once we have that, then we have enough information to use SOHCAHTOA to find our missing pieces. So if we start with the apothem, that one is the adjacent side, and we know the hypotenuse. So from SOHCAHTOA, we know, or we are looking for the adjacent and know the hypotenuse. So we're going to start with cosine of 18 equals a over 12. Once we get here, we can cross multiply and get a by itself. And remember, you should not type anything into your calculator until you are plugging in the area formula. So this is our apothem. We're going to leave it in terms of cosine until we find our area. All right, next we're going to find our x, and x is the opposite. So we're going to use that one and the hypotenuse because we know that exact length. And opposite hypotenuse is sine. So we can use sine of 18 equals x over 12. And once you do that, you'll cross multiply and you would get x equals 12 times the sine of 18. Once you have that x value, then you can find the perimeter. So we're going to take that one piece, 12 sine of 18. We're going to first multiply that by 2, and that's going to give us the length of the side, or the side length. And then we're going to multiply that by the number of sides to get our total perimeter. And this one had 10 sides, so we're going to multiply by 10. And again, we don't want to type it into our calculator until we're plugging in that area formula. So we're just going to multiply these numbers we're not taking the sign of. 12 times 2 is 24. 24 times 10 is going to be, 24 times 10 is 240 units for our perimeter. And then we keep the sign of 18 there. Once we know the apothem and the perimeter, then we plug it into our area formula. So area equals 1/2 times the apothem, which was 12 cosine of 18, times the perimeter, which is 240 times the sine of 18. And then that is where our calculator comes in. So let's grab that so we can type this in. So we're going to have 0.5 times 12 cosine of 18, don't forget that parenthesis there, times 240 sine of 18. So the area of this shape is going to be about 423, and then we're going to go to 4 decimal points, 2054, and that would be our area for this shape. Okay. If you have any questions, make sure you let me know. For the homework, remember you have to show your work to get credit. So write down the formulas that you are plugging into your calculator and show all of the work that you are going to do. Some of them are only going to have one step where you write down the area formula and then you write down the answer. Other ones are going to have a little bit more work to show. So make sure you are doing that so you can get credit on your homework.